Right, as promised from the previous video, I'm going to attempt to explain how my little board works. Right, so let's have a look at the schematic. This is all our sort of floppy drives down here. They're sort of that way. All the control signals are pulled up internally in the drives by 1k resistors, so they're all pulled up. They're all active low. So effectively, if you want to turn the motor on, you need to pull the motor line low. If you want to select the drive, you need to pull one of the drive selects low. So for a start, let's have a look at the motor control part. This consists of these 4 Schottky diodes. Now, what happens if we look at, say, drive 0 is selected, this line will go low. That will cause current to flow around here because that diode is forward biased, and effectively this being low will pull this to about, I don't know, 0.3, 0.4 of a volt maybe, because these are Schottky diodes and they've got a very low forward voltage. That's why I chose them. And in the same way, if drive select 1 went low, the current would flow through this diode, and so on, DS2 and DS3. So that's how it turns the motor on and off. Now, I suppose the obvious question everyone's going to ask is, surely that's not going to work, because if you suddenly turn the motor on whilst the drive's being accessed, the drive's not going to have time to spin up to speed and everything's going to go horribly wrong. But there is something quite different at play here, because if you look at your actual floppy manual, and here I've done it on a scope just to prove that it's actually true, these are the index pulses along here, and this blue trace is the back side of the select pulse, and you notice that there's no index pulses during the first 500 milliseconds of this trace. Now what that does, the drive won't start to try and process data until it sees index pulses, and that's how this works, because quite cleverly the drives blank all the index pulses out for the time it takes the drive to spin up, which is this area here. So that's why it works. If you consult the floppy drive manual, it actually describes this process. So that's the answer to that question. If we go back to here again, now the other thing it does via these other 4 diodes is swap the side. Now normally we'll be working on the bottom head, because the MDS only sort of understands single-sided drives, but what we can do is we can sort of create another drive by using the other head, and that's what this circuit does. So drive select 0, perfectly normal, switch the motor on, nothing else exciting is happening. But if drive select 1 goes low, if we follow this round, it's going to pull the side select down via D1. However, one thing we've also got to do is, if we don't pull drive select 0 down at the same time, the drive won't be running. So it does sort of 2 things in one. When DS1 goes low, it pulls the side low, and it also pulls DS0 low via that line there. And exactly the same thing happens with DS2 and DS3. So DS2 can work quite happily on its own, turns the motor on, everything's fine, it's on the bottom head. If DS3 goes low, we can see pulls the motor on obviously, but it also pulls the side down, and at the same time it pulls down DS2 via that diode there, and that means that makes sure that the drive is actually running, because we haven't got a full complement of drive selects here. We're actually sort of synthesizing one of the drive selects. So that, I think hopefully that explains it. So that's the main principle of it all. So effectively, if we've got, let me just get a floppy drive. I'll show this in more detail in a minute anyway. So we've got a floppy drive here. So drive head 0 is on the bottom, head 1's on the top. So when the side goes low, we select the top head. But we do have to make sure we've still got the drive itself selected. So if this was drive 0 nominally, it's only got one select on the back of the drive, obviously. That's the way it works, because on a normal system a PC will know how to keep the drive selected and switch the head, but we can't do that. We can only do it by using another drive select to actually swap sides. That's why we need to keep, if we're on drive 0 and we want to select the other head by using DS1, we need to pull DS0 low as well. That's the necessity for the other diodes. So that's how that works. So what I'll do, I'll set it all up on the MDS and do a little demonstration. There is sort of there's multiple ways you could configure the boards depending on what you want to do. This one I've just built with just these 4 diodes here. So this just does motor control. So all you have 4 drives effectively, and this board has got all 8 diodes on it, and this will give you 2 effectively double-sided drives. So it just depends what you want. So you can have 2 drives with that one using both sides, or you can have all 4 drives with motor control with this one. Okay, I'll set things up and then we'll see it work on the MDS. Right, okay, all set up to go. Just to prove a point, I've got my board installed at the moment, but the motor on jumper on the board is still actually on. Now this will just prove that the motor will run all the time with the floppies in. So what I'll do, I'll insert the floppy. This is drive 1, by the way. Now as you can see, as soon as you put the floppy in, it's going round and round and round and round. We haven't pulled a directory on there, so that's what happens there. So let me just pull the jumper off. Right, oop. Right, the jumper's off. Now let me insert the disc now. It spins initially just to center the disc. That's just something that's built into the drive. Now what should happen now is, if I do a directory on either of the discs, that motor will spin up. So let's try that. So I'll just do a directory on drive 0, and we'll see, you should see the drive light will come on here, but both the motors will spin. So there we go. The reason both motors are spinning is we've only got one motor select line across all 4 drives. This is drive 0, that's drive 1. Same thing will happen if I pull the directory on drive 1. There we go. In a way, this is quite useful, because if you're sort of working across 2 drives, it means there's no delay on copying a file. If we were to, let me just have a look. If we do, let me just find a file to copy. Let me just copy that test.lst over. The test.lst. I'll copy that over to drive 1. So if you watch carefully, we should see the select come on while it loads copy. Then it should start copying across. So you see this drive was already running even before the light came on, so obviously that speeded things up. So there we go, and now it's stopped again. And this is fairly crucial to the longevity of your floppies, really, and your drives, because you might say, oh well, yes, 8-inch drives run all the time, so what you worried about. The difference is, yes, an 8-inch drive does run all the time, but it's got a head load button on it, and that means that when the head isn't loaded, i.e. the drive isn't selected under normal circumstances, there's no pressure sort of pressing down on the head and the disc. Whereas with drives like this, as soon as the drive light comes on and the motor starts running, then you've got pressure on the disc, because there's no head load in a 3.5-inch drive. As soon as you put the disc in and the sort of clamp comes together, that's it. It's clamped the disc, and you've got pressure on there. The motor spins up, then you're causing wear. So, and that's what's happening there. So that's the normal setup with just the motor on off. We're not selecting drive sides at the moment. So what I'll do, I'll put the other board on this one here, then I'll show you how we can use both sides of the drives. Right, I've got the full board installed now with all 8 diodes. So we've got motor control now, and also we've now got drive 0 on the bottom head. We'll have drive 1 on the top head. We'll have drive 2 on the bottom head on this one, and we'll have drive 3 on the top head on this one. Right, so let's do just a directory on drive 0. So the light will come on that drive, which it does. And if I do a directory on drive 1, you'll see the same light will come on, but this time we'll be looking at the other side of the disc. So let's try that. There we go. As you see, we've got completely different directory listing. Now if we can do the same thing on this one here, I'll do directory 2, which will be the bottom head on this drive. And if we do directory 3, that will be the top head on that drive. There you go, again, completely different directories. No problem running something, if we look at was on drive 2. Oh, hang on, let me just try something that's a bit easy to demonstrate. Let's try drive 1. There we go, we've got basic on that one. So let's try and run basic off of drive 1, which is on the top head. So if we do :F1 : basic. There we go. It's basic running. Copying is no problem either. We could go there to there, up there, wherever way you want really. I'll do copy :F1 : let's copy it to 2, okay? It's reading off of drive 1. There we go, and now we've got basic on drive 2, so we can do :F2 : so there you go, that's how it works. So effectively it gives you 2 more drives, but with only two actual physical floppy drives. The cabling is quite specific, as I showed you on the bench. I'm not sure if you're not going to be able to see it. I will move the monitor out the way, but this drive here, which is 0 and 1, is plugged into FDD0, and this drive here, which is 2 and 3, is plugged into FDD2. That's just to get all the drive selects in the right place. So that's pretty much it and how it works. If you want to build the board, I've already uploaded the schematics and the Gerber files. I've used JLC PCB, and they're very cheap. and the quality is very good as well, so I would recommend them. I will try and do some bills of materials for it as well, and some hints where you might get some of the parts, but they're fairly straightforward, to be quite honest. A lot of the headers are just sort of standard Arduino single or double headers. The diodes I think were backed 42s, but they're not critical. You don't necessarily need to use Schottky diodes. It just gives you a little bit more headroom. It's more likely to work in extreme circumstances. So that'll do it for this one. Hope you enjoyed the video. If you did, give me a thumbs up, and I shall see you next time.